goes. Okay. Here's the next one. Amazon Athena adds visual query analysis, tuning, and tools. So,
Yep.
oh, sorry, go
This
ahead.
is almost like the query planner that you always wanted for Athena. And we are just so used to writing up the queries that make intuitive sense and then starting to observe the performance of our queries before we can start optimizing them. And we've come to rely on these query analysis engines, to help us fine tune and refine our queries so much, because when you have parameterized queries in particular, you really don't know how people are using it. You don't know how it's affecting the performance of your queries. The fact that these tools are now available makes a big difference to the cycle time of creating these Athena queries and making them available to all the other tools that leverage them, whether it be QuickSight dashboards or any other downstream system like Glue or whatever other job you might be doing. So a huge win for sure.
Yeah, it's really easy to have. Well, if you're not careful, you can wind up with a full node scan popping up. And think, okay, great. Now, you've lost all the advantages of your index, and you're just looking at every last entry. And yeah, that slows things down substantially. And being able to spot that visually rather than looking through logs, that's fantastic.
Yeah. Actually, sometimes Athena is fast enough that you don't realize it, but it does massive scans at times, and then it shows up in your bill a month later. And it seems really, really scary when something like that happens. And it's really hard to interpret how a certain SQL is going to be, or I'm using the word interpret twice, but it's really hard to figure out how the database engine is going to, or the Athena query engine is going to interpret the query, the SQL query you write, in terms of how it executes it under the hood. Until you see the query plans, until you see these debugging markers, till you see them, you're not going to be able to figure out what the problem is. You wouldn't know why you got a massive bill. You wouldn't know why your queries are slow, because you just don't understand enough about how the SQL that you wrote is getting interpreted by the engine. So having this data now is incredibly valuable in simplifying and better indexing the data, or better organizing the data so that it gets indexed and queried effectively by Athena.
I think that one of the things that with SQL, where it's both a strength and a weakness, is that you can do something that's phenomenally complicated. You can look at views calling stored procedures and views and views and views stacked on top of each other, and it will just chug through it. And it might be really slow, but it usually finishes and does the right thing. But like you said, it can lead to either a complexity explosion or a cost explosion or a time explosion. A quick story about a company that will remain nameless. I was doing some consulting, and they wanted to know why their Tableau dashboard took so long to render. And they were thinking it was a Tableau problem, but the underlying data query took about 57 seconds, and the Tableau dashboard took about 58 seconds to render. So, okay, it's not in this case, it wasn't Tableau's fault. It was the fact that it was views on views on views on views, and it was, full node scans on top of another. But it's easy to do. It's easy to get to that situation if you're not careful and if you're not in a hurry, right? They say, oh, a minute's fine or 30 seconds is fine.
Yeah.
But when you're paying for it by the query, it's a different situation.
Yeah. And I think in the case of Athena, this actually gets a lot more complicated. Given that Athena can actually operate on a large number of different kinds of data stores, the interpretation of what a SQL means for a different data store might actually be different. So what comes intuitively in your head as you're writing a SQL may be interpreted differently if you are using Athena to talk to Aurora versus Redshift versus S3 versus DynamoDB.
Yeah, so your mental model gets a lot more complicated. Okay, this piece of
Correct.
the data is actually loading in a Parquet file in an S3 bucket or something like that.
Correct. Exactly. And does it change if you're picking up a Parquet file versus, say, just a CSV or a JSON file? Like, how does it deal with all of that complexity? And how does it interpret SQL? So, unless you have that query plan, unless you have those query statistics, it's going to be really hard to get to the root cause of either a slow query or excess costs or, you know, yeah, any of those kind of symptoms.
And then I see that as part of this, they've got this new query statistics API. I haven't used this. Have you used it yet?
Not
Runtime
yet.
query statistics.
No, I think this might be relatively new.
Yeah, they mentioned that in the article. They said it's new. Yeah, metrics are displayed as an embedded
Yeah,
console
to a new
visualization.
query statistics API.
Yeah.
So what all does it tell you? Let's look at some of the stats that it shows us and let's try to see if these are valuable. So you have runtime statistics, which is execution time, which is great. Input bytes. Input bytes is neat because it actually, I'm curious, is input bytes the number of bytes that you actually had in the query itself? If it is a parameterized query, that could change. Or is it the number of bytes? No, it's probably that. Output bytes is the resultant data set. Query stage plan. This one is your query plan, basically. And it's looks like a list. So that's pretty neat. That's going to be very, very valuable. And then let's look at the rows. So you have inputs and outputs total and how many rows got returned. Great. Then I'm just wondering whether you get numbers per stage.
Well, I was just
Unless the
thinking
query
about
stage
that
plan node.
because
Do
you'd
they have the
want to
definition
know.
for the do they have the definition of the query stage plan node?
Let's see.
On the left hand side, you might see data types. Yeah, query stage plan type. Yeah, no, it was right there.
Query stage plan node.
Yeah, so remote just go up.
Children. Stage plans such as name, identifier, subplans, remote sources. That's interesting. So you get the remote sources, like you're saying.
Yeah.
Um,
So it could be a DynamoDB, it could be Redshift, it could be S3, it could be any of those sources.
and it's interesting, even if you don't have an immediate plan of how to use this data, I find that just having a glance at the underlying data, and this is a general thing, it always
Yeah.
helps, right? Because then you know if something big changed, right? Like if your
Right.
rows in is many order of magnitudes bigger than your rows out, then maybe you want to change where you're filtering versus where you're joining versus it's easy to
Correct.
say select everything and then filter at the end, but then you make your database work a lot harder. Maybe you want to
Correct.
filter earlier and get your rows in and rows out a bit closer. There's a lot of things that just can, even if you haven't done the proper analytics, just having a gut feeling of what's right for your particular job, and then it can alert you when something changes. That's good to know.
Correct. And actually, the mental model that you just described, where is it a filter first? Is it a scan of a big chunk of data and then a filter and then, picking the data elements that you want, or is it a filter first and then scan that's happening later? Like that mental model that you have for SQL may not actually apply the same way when you're talking about document DB or DynamoDB or any other data source that is available as part of the adapters. Like that interpretation of what it means, what the where clause will do and what the select will do and in what order it'll execute those things, you will not know about it till you actually see the query plan.
Yeah, I mean that's. I guess this all goes back to Don Knuth and saying premature optimization is the root of all evil, right? Just because I have this mental model and I might write my queries a certain way, and I might learn that I'm optimizing towards a constraint that stopped being binding a long time ago.
Correct. Correct. Yeah, and the SQL query engine is also going to have optimizations in there, where if it knows enough about the schema, it could actually make a bunch of decisions. We don't even know what decisions it makes. Like if you look at the Redshift query planner, There are a ton of optimizations and stuff that it does under the hood to make sure that it can partition those queries across different data sets effectively. It pulls in all the data from all the different computes, aggregates it, and brings it back to you. That, you wouldn't even know about if you did not know that there was a query plan like that under the hood.
So really not try to prematurely optimize or kind of outsmart the query planner, almost write it naively and then see where's the slow point.
That's one way to do it. Keep it simple, do it fast, get more data into it, start analyzing the results, look at anomalies, fix them.
Perfect.
So,
Well, I definitely will be looking at this this API, the Query Statistics API. Well, it looks like we are just about out of time. I think this is a really fun session.
Absolutely.
Oh, do we say we give this a simplifies?
I think so. I think instead of guessing at your query plans or what Athena is going to do, the fact that you now have the query plans and the stats makes life a lot simpler in terms of how you organize your queries. So yes, definitely a simplifies.
Wow. Well, that was 5 simplifies out of 6 and only 1 too complicated for the and that even too complicated had an asterisk in that it's not quite what we wanted, or there could be more data about the AMI.
Correct.
It's pretty good. 5 out of 6. That was nice work, Amazon, this week.
Absolutely. Look forward to next week. And I know that there was a barrage of announcement that just happened very, very shortly before this particular live stream. We've not been able to analyze it and go through it, but we're going to do that next week.
All right. Well, we'll talk to you next week. And thanks again. And thanks, Raul. We will see you, everyone. See you next week.
Thanks, everyone. See you soon.